All right, these are going to be this is going to be your introduction to exponential functions. So I'm just going to take you back just a little bit to the two things we've already covered. The beginning of the year, we mostly talked about linear. This would be lines. We can easily recognize them on a graph. They're also easy to recognize in an equation. For instance, this would be your linear equation. So we have covered lines. We also covered quadratics, which are easy to identify on a graph because they look like a U-shaped figure. It could also go upside down. And then we always know it's quadratic when we've got that square in there. That always helps us determine if it's quadratic. But there is a third type that we're going to discuss now, and that is exponential. So these graphs are unique in the fact that they slope up a little bit or down, but they never actually cross this x-axis. So they're very unique in that way. And it doesn't make a complete turn either, like a parabola does. So exponential can also be easy to identify. They are typically written in this form, AB to the x, and we're going to talk about what these mean in a minute. But one of the things I want to review is how do you know if you're looking at linear, quadratic, or exponential when you're looking at a table? Because in your calculator, if you go to put your table into stat edit, you are going to be able to calculate the equation when you do stat calc, but you have to make a decision. You have to decide if it's a line, if it's a quadratic, or, and we'll go down to exponential, if it's exponential. So see the EXP here? So you have to make a decision between those. If it's number 4, a line, number 5, a quadratic, or number 10, an exponential. Because otherwise your calculator won't give you the right equation. So for example, here I've got this graph. If I wanted to write the equation from this graph, the first thing I would want to do is pull points. On a line, you only need 2 points. So I'm going to go ahead and pull those. Here's one. I really like positive numbers, so I'm just going to pick these two. So my first one is, let's see, this counts by 2, so 0, 4. And my second one is 2, 8. Let's go ahead and pick a third one just because. -4, -4. So when I go to type this in my calculator, I hit stat edit, and then I can type in my points. And now I'm going to let the calculator calculate my equation. So I hit stat, and then I go over to calc. And I know this is a line because I'm looking at the graph and it looks like a line. So I'm going to hit number 4, enter, 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 calculate it. And it gives it to me in linear form. So that means that this equation is y equals 2x plus 4. You would typically do the exact same thing with the quadratic. You want to be purposeful about the points that you pick. So I'm going to pick the vertex and put it here in the middle. And then I'm also going to pick a point on the left and then its opposite point or its reflecting point on the right. So I'm going to pick this one, which is 0, 5. And then over here, I've got 4, 5. I'm going to walk through the same exact process in my calculator. I'm going to stat edit. Let me go ahead and reset this. 2nd plus 7, 1, 2. So that way my table is clean. Put in my points. And now I'm going to calculate the equation for a quadratic, not for a line. So stat calc. And this time I'm not going to press number 4 because it's not a line. I'm going to press number 5 because it's a quadratic. Lots of enters because you want it to get down all the way to calculate. Enter, and it will give you your quadratic equation, which is A is 1, so 1x squared. B is -4, so -4x. And C is 5, so plus 5. Now, Here's why you want to be really specific. If I stat calc and hit number 4 to calculate a line, it's going to give me an answer. But it's not the right answer because it's not a line. That's why it's so important to be able to tell the difference between these two. Because if you accidentally hit the wrong button and calculate, it will give you an answer. And so you'll feel like you're doing it all right, but it's not giving you the answer to the right problem or type of problem, that is. So what's tricky about this is how you can tell from a table. Obviously, you can look at this and know, okay, that's linear, that's quadratic, that's exponential, but how do you do it from a table? So first things first, linear. Linear tables you learned back in 7th grade, I believe, but we'll review those. You know that the changes that create a linear equation are known as change in y over change in x. So all you have to do is see or notice a constant change in y over x, and it's got to be the same all the way through. So from 1 to 4, it goes up 3. From 4 to 7, it also goes up 3. From 7 to 13, do what most people need to do, 6. And then you get your change in x, because it looks like it may be different here. We'll find out. So from 0 to 1, it's 1. From 1 to 2, it's 1. And from 2 to 4, it's 2. So your change in y over change in x here would be 3 over 1. Here would be 3 over 1. And here would be 6 over 2. Well, what does 6 over 2 reduce to? And if you don't know how to reduce this in your head, there is a calculator tool that will help you. So if you hit alpha, y equals number 1, and put your 6 over 2 and hit enter, and it will reduce it for you. So this would also be 3 over 1. So that's how I know this is linear. It's got a constant rate of change all the way through. That way, when I go to put my table in, 0, 1, 2, and 4, One, 4, 7, and 13. Now when I hit stat calc, I know to hit number 4 because I've proven that this is linear. If I accidentally hit number 5, watch what happens. It gives me an answer, but it's not the right answer because this is not a quadratic. This is a line. So this is the answer I'm looking for. Y equals 3x plus 1. So that constant rate of change is what tells you that it's linear. So how do you know that you're dealing with a quadratic? Well, first you prove that it's not linear. So from 6 to 0 is minus 6. From 0 to negative 4, let me zoom in a bit for you, is minus 4. And from negative 4 to negative 6 is minus 2. Now I'm going to check this. Negative 3 to negative 2 is plus 1. Negative 2 to negative 1 is plus 1. And negative 1 to 0 is plus 1. So here I have negative 6 over 1, and here I have negative 4 over 1. So it's not a constant rate of change. So this is how I know it's not linear. So now I'm going to check the changes from here to here and from here to here. These are all the same, so I'm good there. Negative 6 to negative 4, plus 2, negative 4 to negative 2, plus 2. This is how I know it's quadratic. The second rate of change is consistent. So that will tell me that when I put this into stat edit and I stat calc it, I'm going to have to make sure I do the quadratic. There we go. So I need to be hitting, oh, I'm sorry, you can't see that. Quad reg, not line reg. So what I've done is I've put it in my table. and I hit stat, calc, so I have to go over, quad reg, I gotta go to 5. And my equation is 1x squared minus 1x minus 6. So how do you know if it's exponential? Well, I know that your brain is going to do rate of change first. So you're going to see what's being added or subtracted. So I'll do that as well. 2 to 6 would be plus 4. 6 to 18 would be plus 12. 18 to 54 would be plus 36. And you can always check it. You can take this and go 54 minus 18, 36. Now from here to here, it's plus 1. From here to here, it's plus 1. From here to here, it's plus 1. So it's definitely not linear. So now let's try our second rate of change. So from 4 to 12 is plus 8, but from 12 to 36 is 24. So it's not exponential either. I mean, I'm sorry, it's not quadratic either because my second rate of change is not constant. So then what actually happened here? Let's see if it was multiplied. From 2 to 6 is times 3. From 6 to 18 is also times 3. From 18 to 54 is also times 3. This would create the exponential change. This way I know that if I type these numbers into my calculator, -1, 0, 1, 2, 2, 6, 18, 54. When I stat calc, I need to make sure I do exponential and calculate that equation. So here it looks like my A is 6. My B I'm going to put in parentheses, which is 3. And it's always going to be to the power of x here. So that's my equation. Let's talk about this word, asymptote. So the asymptote is kind of like a stopping point. It keeps the graph from going any further down. So for example, if I have an investment account. So here's my investment account. And I put my money in up here. And then over time, my investment starts going down, which sometimes happens. And then it flatlines here. That's good. It's going to get closer and closer and closer to the 0, but it is never going to touch or cross that 0. It's never going to touch or cross this x-axis. So that 0 mark on the y right here is my asymptote because it's never going to cross that. Now, if I had a graph that flatlined, let's say at the 3, like this, and it looks like it may touch the 3 or cross the 3, but it never actually does, then my asymptote would be the 3. Y equals 3, actually. This one would be y equals 0. So that's all an asymptote is where it stops, where that curve starts to flatline. It could also be backwards. So let's say I have a graph that's here and it heads upward like that. You still have an asymptote of 0 here because it's never actually going to touch or cross that 0, even though it's going to look like it. So that asymptote would be 0. So that's all an asymptote is where it flatlines, looks like it flatlines. And it's always y equals. So like this one, probably y equals, I don't know, 1. We'll say that. And then this one would also be y equals 1. I made up that number. That number could be anything. You also need to be able to tell if it's growth or decay. So you need to be able to tell if it's growing or decaying. So let's practice that. So what you're going to do on these is you're first going to get some points so that way you can graph it. So let's start with, I don't know, let's start with 0. If you plug 0 into that x, what would you get? You know, the other way you could do this is put this in your y equals, but let's do it here. So you have 2 to the, and we're going to make that x 0. I get 1. Let's make it 2 to the 1. Let's see what happens. Oh, you get 2. Let's make it 2 to the 2. You get 4. Let's go negatives now. Let's make it 2 to the negative 1. Oh, let's see, that's 0.5. Let's make it 2 to the negative 2. Oh, you get 1/4 or 0.25. So now we can graph that. So I've got -2 and 0.25. So -2, about a quarter of the way. -1 and about halfway. 0, 1, 1, 2, 2, 4. You can start to see that curve now. It's just going to keep going. You could even look at that in your y equals. So if you wanted to graph it here, to just double check your graph, you could put 2 to the x. So just type it in exactly like I see it and hit graph. Same thing. So what would our domain be? So you're going to go Dixie for domain and then Royd for range. So here's Dixie. Dixie's going to go left to right. So does Dixie stop here? And the answer is no, because there's an arrow. Does Dixie stop over here? No, because there's an arrow. So since we don't actually stop anywhere here, this would be all real numbers. Range is Royd, and Royd lifts. So normally we would say no, it's not going to stop here, but remember what we discussed about asymptote. If you look at this graph on your calculator, it never actually went below that x-axis. So there actually is a bottom here. It just doesn't touch that. It just keeps getting closer and closer and closer and closer and closer and never touches. So I can prove it to you. Let's go to the table. So half, 0.25, that's what we have here. Half, 0.25, 0.125, 0.0625. Will we ever be 0? Will we ever be negative? No. Look at that E. That's so weird. That means it's a very tiny number. So we just get closer and closer and closer to the 0, but we never actually touch it. So Royd does have a base here at 0. It just never touches the 0, so it's not equal. And then range goes all the way up to the top. Does it ever stop here? No. This is going to keep growing up and up and up and up and up because it's growth. So that side would be all real numbers, which means we don't need that side. What is your y-intercept? That would be 1. So 0, 1. And your asymptote is that space that it never, ever touches. So that's at the y at 0. It's never going to touch that. Let's do another one. So this one says f of x. That's so weird. That's the exact same thing as y though. So you could actually change this to say y equals, and you could use your calculator to graph it if you'd like. You can also use your calculator to get you some points. So if I type this in exactly like I see it, let's close our parentheses there. So I've got parentheses 3 over 2, parentheses to the x, parentheses 3 over 2, parentheses to the x. You can even look at your table to grab your points. I'm going to go back down here to closer to the center of 0. So I see 0, 1. I don't really like these fractions, but it looks like I don't have a choice. So 1, 3 over 2, 2, 9 over 4. Let me go back to -1, 2 over 3, -2, 4 over 9. Now, if those are hard for you to plot, don't worry. So for instance, I know I'm going to go back 2, and then let's say I don't know what 4 over 9 is. So if I just do 4 divided by 9 on my calculator, I can see that it's a decimal, kind of close to 0.5. So I'm going to go to -2 and then kind of close to 0.5. -2, then kind of close to 0.5. If I don't know what 2 over 3 is, I can just do 2 divided by 3. So I'm going to go back 1, -1, and then a little more than 0.5. So right here. 0, 1, that one's easy. 1, 3 over 2. If I don't know what 3 over 2 is, I can always do this. So it's 1.5. 1, 1.5. And then 2, 9/4. So 2, and then it's a little more than 2 when you type it in your calculator. So it looks like I'm going to go like this. Is that growth or decay? And then you'll check your domain. Is it ever going to stop on the left? The answer is no. Is it ever going to stop, even though it's never going to cross the x? It's still never going to stop. And is it ever going to cross over on the right? The answer is no. So your domain is all real numbers. But keep in mind there's an asymptote. And that asymptote is going to be the bottom of your range. It's never going to touch that line, but it's definitely going to be the bottom of the range. So that's our asymptote. I'm not going to put anything on the right because, again, it doesn't stop up here. And my y-intercept is 0, 1. So you're doing the same thing on the next 4. And then so hit pause and do the same thing on the next 4. And then the rest of this video, there will be no audio, but it will walk you through very quickly to check your work.